friends, in this video we will study about the pressure measurement device diaphragms. Here we will study the construction, working principle, the types of diaphragms, their advantages, disadvantages and applications of these diaphragms for the measurement of pressure. So let us start with our topic. Diaphragms are the pressure sensitive primary devices which are used for the measurement of pressure at the primary stage. Means they are going to measure the pressure of the fluids by converting it into the displacement. So displacement is measured in terms of the pressure. The other pressure sensitive primary devices are the bellows and the Bourdon tubes. So these pressure sensitive primary devices, they consist of an elastic material which is going to deflect or expand or contract when the pressure is applied on them. So due to the expansion or contraction or due to the deflection of the elastic material, a displacement is caused, and this displacement is proportional to the pressure applied or the pressure of the fluids. So by measuring the displacement or the deflection of the elastic material, we are measuring the pressure. So that is the working principle of the diaphragms, that in the diaphragm also they consist of an elastic material which is going to change its shape when the pressure is applied on it. So by measuring that deflection, we can measure the pressure. So we can say that the working principle of the diaphragm is that the pressure which we want to measure is applied to the diaphragm, causing it to deflect, and this deflection is being proportional to the applied pressure. Now the movement of the diaphragm, it is affected by the, or it depends upon the thickness and the diameter of the diaphragm. If the diameter and the thickness is less, then the diaphragm is going to move larger, or larger deflection will be produced. So the movement of the diaphragm, it depends on its thickness and the diameter. Now the unknown pressure which we want to measure, it is applied on one side of the diaphragm, and the other side, it is the edge of the diaphragm, it is rigidly fixed. So when pressure is applied, it is going to change its shape, it is going to expand. Okay, ends, the edges are fixed, but the middle part is free. So when pressure is applied, it is going to get elongated in the shape. So the edges of the diaphragm, they are rigidly fixed, and they causes the deflection on account of the applied pressure. And this deflection, it can be measured to determine the applied pressure P. So in this way, pressure is measured by measuring the deflection of the diaphragm. Now comes the construction of the diaphragm. The material of which the diaphragms, they are made up of, they are a very thin membrane diaphragms, so that when pressure is applied, they can flexibility is there due to the thin membrane, and they can easily expand and contract. Now the diaphragms, they come in the two types. One is the flat type of diaphragm, and other is the corrugated type of diaphragms. The difference between the flat type and corrugated type of diaphragm is that in corrugated type, the surface area is being increased due to the zigzag configuration of the diaphragm material. If we see their shape, flat type is in which we are having a flat configuration. In corrugated type, cross section. So in the corrugated type of diaphragms, we are having increased surface area, and due to that, they give us the greater deflection, and greater deflection means that higher pressure ranges or higher pressure measurements can be done. Now let's see that how in the flat type and the corrugated type of diaphragms, the deflection is proportional to the applied pressure. So this is a flat type of diaphragm. You can see that earlier the diaphragm was in the flat condition. Okay, when pressure is applied to it, its shape is being changed. The edges are being fixed. Okay, so only when the pressure is applied, the middle part is going to expand. So here the shape of the diaphragm has been changed. The R is the radius, D is the diameter, T is the thickness of the wall of the diaphragm. So let's see that how the pressure and the deflection of the diaphragm, they are related with each other by the formula. So the applied pressure P is equals to 256 ET cube dm divided by 3 1 minus V square d to the power 4, where P is the pressure, E is the Young's modulus, T is the thickness, D is the diameter of the diaphragm, V is the Poisson's ratio, R is the radius, and dm is the deflection at the center of the diaphragm. So if you see this relation, then pressure is directly proportional to the deflection of the diaphragm at the center position. Pressure is directly proportional to dm. So the relationship between the two is a linear relationship. And this linear relationship, it holds as long as the deflection is less than or equal to 0.5 t. The deflections greater than this value, the relationship will not be linear, it will become non-linear. So linear relationship is going to hold as long as the deflection at the center of the diaphragm is in the range less than equals to 0.5 t. Now, if we write the formula for the deflection at the center of the diaphragm, from this formula, if we derive its value, it will be 3p multiplied by 1 minus v square d4 upon 256 et cube. Okay, so dm is equals to 3p 1 minus v square upon 256 et cube d to the power 4. Now d is the diameter, so if we write it in the terms of the radius, so diameter is equals to twice of the radius. So here we are going to write 2r raised to the power 4. So in that case, the deflection will become 3p 1 minus v square upon 16 et cube r to the power 4. Because 2 raised to the power 4, it is 16, and 16, if we divide this here, we will get 16 value. So this is the deflection at the center, dm. Now if we want to find out the deflection at any radius r, this was the deflection at the center. Now deflection at a radius r from the center will be dr equals to 3p 1 minus v square upon 16 et cube, and here instead of r we are going to write r square minus r square to the power square. Okay, so because the radius is at a distance r from the center, so this is the deflection at a radius r from center. Now maximum stress at the circumferences, maximum stress is given by when the 1 minus v square value is neglected, so it is will be 3d square p upon 16t square. Now the lowest natural frequency is Lowest natural frequency for air and gas medium is given by 20 T upon D square under root of E upon 3 rho multiplied with 1 minus rho 1 minus V square radians per second, where rho is the density of the diaphragm material. So these equations are used for the flat type of diaphragms. If we talk about the corrugated diaphragms, and also we have said that these relationships, the linear relationship between the deflection and the pressure, it exists only when the deflection at the center is less than equals to 0.5 for T. Now for the greater deflections from this value, that is for to get a deflection greater than 0.5 T, the corrugated type of diaphragms are used. So corrugated type of diaphragms, they are suitable for applications where a mechanical device is used for the measurement of deflection. This is because the corrugated diaphragms, they give a relatively high output, and if they are combined with a mechanical device which is giving higher amplification, so it is so we can get a relatively or a greater output can be obtained. Okay, because they are initially they are giving us the high output also, and if they are combined with the mechanical device which is also providing further amplification to the deflection, so we can use these corrugated diaphragms for the direct operation of the or direct measurement of the pressures. Now, there are some cases in which the diaphragm, it consists of a single disc only, and there are some cases when the diaphragms, they consist of two or more discs. In that case, they are known as the capsules. So the diaphragms, they generally they consist of a single disc. As you have seen in the diagram, we were having the flat diaphragm. So when pressure is applied, it gets deflected. Now there are sometimes when two diaphragms, they are bonded together at their circumference. Means at one diaphragm will be like this, and other diaphragm will be like this. They are joined together, and they are their circumference, they are joined together by soldering or the pressure welding to form a capsule. Okay, so such type of diaphragms which are a combination of two or more diaphragms which are joined together, they are known as the capsules. Let us see the diagram of a diaphragm which is consisting of three capsules. So this is the diaphragm element, which is consisting of 3 capsules. These are the 3 capsules. You can see here it consists of 2 diaphragms which are joined together. It is the free end of the diaphragm element and it is the fixed end. Now, when the pressure is applied on this diaphragm element having the capsules, so each capsule is going to get deflected. So the total amount of deflection, it is the sum of the deflections caused in each of the capsules. So total deflection is equal to the pressure applied on the diaphragm element. So here you can see in the diagram that each of the capsules, they are connected axially with each other. One capsule is connected with the next one. Individual capsule is connected axially with the next one and is allowed to expand without any restrictions or any restraints. So when the pressure is applied on this diaphragm, each capsule is going to get expand due to the pressure applied, and the total deflection of the diaphragm, it is the sum of the deflection of the individual capsules. So here this configuration of the diaphragms is also used for the measurement of high pressures. Now let's come to the materials which are used for the measurement of for the construction of the diaphragms. So the materials which are used for the construction of diaphragms are they are used phosphor, bronze, stainless steel, beryllium, copper, nickel, spancy, inconel, monel and nickel can be used for the construction of diaphragms. Now in some applications the non-metallic materials are also used. Nylon and Teflon. So in some applications where the environment is going to corrode the metals, so in that cases non-metallic materials like Buna and rubber, nylon and Teflon are used for the construction of diaphragms. Now if we talk about the applications of diaphragm, they are used for the measurement of pressure. Generally the low pressures are measured, including vacuum. So the pressure range is 0 to 50 Newton per meter square to 0 to 200 kilonewton per meter square. Also the accuracy provided by the diaphragm, it is plus minus 1.25% of full range. So this was the applications of the diaphragm. So here in this video we studied about the pressure measuring devices, the diaphragms. We studied the various types of diaphragms, flat type and corrugated type. We studied that the deflection is proportional to the pressure. We saw the formula for it, and then we saw the capsule form of diaphragms also, in which the diaphragm elements are in the form of capsules. After that, we studied the materials, the advantages, disadvantages, and the applications of the diaphragms. So I hope that this topic is now clear to you. Thank you.